Would you like to grow up to be a Beatle?
Killer hell, killer hell, killer hells, killer hell, killer hells, killer hell. 10304 style kid for my DMD rank posse niggas. You out there?
Welcome to chapter 14. This chapter deals mainly with oscillatory motion, and the best way to start tackling this topic is to look at spring mass systems that is shown here. So we have a mass M attached to a spring that is attached to a wall. In this first picture, the spring is uncompressed and also unstretched. So the mass is sitting at a place called equilibrium position. It doesn't want to move anywhere because the spring isn't exerting any force on it. But now let's move this mass a little bit to the right by amount of x. Then we have a force acting on it because the spring wants to pull it back. We can model this kind of system physically by saying that the force acting on the mass equals some constant k, it's known as a spring constant in this case, times the displacement from the equilibrium position. So here we can see we move it to the right by x, and then the force F will try to bring it back. And when our displacement is to the right, we can see that the force is acting to the left, and in physics the direction always matters. So that's why we have to have the minus sign here. So if you move the mass to the right, the force will be to the left. And if we move the box to the left, like in this case, the force will be to the right. Hence the minus here. This kind of physical dependence is known as the Hooke's law. Whenever the restoring force F is proportional to the displacement, we call it the Hooke's law. And the proportionality constant in this case is k. And particularly in this case, it's called the spring constant. Its units are newtons per meter. So if we have a large K spring that has a large spring constant, it means that to move it a little bit requires more force than if the spring constant was lower. So a stiff spring has large spring constant, and a loose spring has a small spring constant. So the dependence is linear, and this is kind of intuitive. So if you think about stretching a spring, first it is easy when the displacement is small, but if you have to stretch it a lot, you will require more force.
Crowd pleaser, register off the meter. Vocal street sweeper, buckshots through the speaker. Pleasure seekers, 50 thou in the stands. True fans get it hot like Jamaica sand. Conquer land wide like an eagle wingspan.